All right, so I'm going to leave it to Patrik Fältström for the first presentation. Let's give him a big hand.
Oh boy, that's bright. Oh. It's like waking up in the morning and asking wherever you were yesterday. It's like, yeah, I had a beer. So, anyway, so I'm head of research and development at Netnod, and I will mention a little bit what we are doing a little bit later. Not so much in the cloud business yet, but we are doing things that you might rely on. So it might be the case that you actually should know we exist, so you can call us if something doesn't work. This is sort of my motto. I've been working with the internet for quite a number of years, and I really think one should really use the internet as it was, sort of as we wanted from the beginning. And this is sort of also what is needed for your service to work, right? So to start with, to explain the problem with traffic that I'm going to talk about, I need to talk a little bit and remind people about what kind of changes we have had lately. Because some people are old, like me, are old enough to remember when we only had one telco. They had some services. Everything was TDM-based. In many places in the world, it was illegal to use IP. They sold the end equipment, which meant that they also decided what color it was on the phone. And call forwarding and sort of star 21, star blah, blah, blah was the most fascinating thing that existed. And when they launched a service, they wrote about it in the daily news, right? 3 services a year. And how many apps do we get each second on App Store? So this is only 35 years ago. But what's more important is that as we only had one telco, they were responsible for all services. We had no regulator, because PTS, the regulator in Sweden, did not exist. And that meant that all legislation we had, if any, were targeted at the one organization that were delivering the services. Okay? And they were owned by the government. This is a very big difference from what we have today. 20 years ago, we started to get competition. We got packet-based communication, and we know what sort of good things there are with packet-based instead of TDM-based. We had the first political decisions, and this is really important compared to roads and some other, like, we had the deregulation in roads, we had deregulation in trains, we had deregulation in electricity, we had deregulation in telecommunication. For some weird reason, when deregulating one of these areas, we, as in Sweden, do not look at the failures and successes in the other areas. So each one of these areas have failed in one very successful way. And of course, we failed in the telecommunication side as well. So I was one of the persons at the Royal Institute of Technology, KTH, that started to build SUNET in Sweden. So I scanned my old slides. So 1989, we had SUNET 1.1. And you can even see sort of the subnets on the map. And the number of routers we had in Sweden was probably the same number of routers that each one of us have at home. Okay? We had a 64 kilobit satellite link to John von Neumann Supercomputing Center in the US for all of the Nordic countries together, and it was not full. Okay? 1989. This was internet in 1989. You had IP with us, Nordnet, in Netherlands, in Italy, in Italy and Switzerland, and a university in France, and then in the US. Nothing else. In Germany, it was illegal. Okay? And by the way, this one thing I forgot. So we actually started, we tried to convince Televerket, the incumbent, to run IP, failed, so we went to Tele2, and they said yes. To be able to, when we wrote that agreement with Tele2, we agreed that for the first 5 years, an organization called Swedish Network User Society was to decide and have influence on what products was to be delivered by what was called SWIPNet for the first 5 years. That organization, SNUS, was founded today, 25 years ago. Yes, I happen to today be chair of the organization, and yes, we have a big party on Monday. So anyways, so we have had competition regarding internet in Sweden for now around 25 years, not more. Important to know. The second thing that is important to know is that we originally had telephones for doing voice calls. We had a TV for moving pictures. We have a radio for audio. And we had one connection for each one of them. Okay? But what has now happened over time is that, of course, everything is now communicating over IP. And anyone can produce and provide a service. So today, we don't really know not only the difference between a TV and a phone, we also don't really know the difference between the provider of television from a provider of telephony. Because we don't really know, we don't even know the difference between television, between radio and TV and whatever it is. And what is even more important to remember, and this has, once again, has to do with the sort of unwanted traffic, more and more, each one of us is running part of the infrastructure. Remember now, for 35 years ago, we had one incumbent that was running the services. But today, anyone that brings something and connects it to the internet, regardless of whether it's a wire, whether it's a CPE, whether it's a router, whether it's a service, whatever you connect to the internet ends up being part of the internet. And when you have connected it and it becomes part of the internet, you are responsible for that piece. So we have a shared responsibility to make sure that the internet works. So myself, I'm a little bit allergic against these pictures that say, oh, I have my network, my routers, and maybe some of you will show those kind of slides later tonight. So I'm sorry, apologies in advance. But anyways, you have these things, blah, 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 blah. And then we have this connection, and over there is the internet. That is wrong. Because whenever you have connected something, it ends up being part of the internet. So whatever is unwanted for you might be okay for someone else. And that's what I will talk about a little bit. So here it is. So the important thing here is that when we talk about robustness and the ability to deliver, we have to remember that to start with, you have to make sure that whatever you are connecting to the internet, whatever you are bringing to the internet, your piece of the internet, it's your responsibility to ensure that that thing works according to some definition of works, and I will come back to that. Same thing at home. You don't ask the road authorities to sort of keep burglars out. You have an advocate level of lock on your door, which normally is a little bit better than your neighbor. You have a little bit fancier stickers than your neighbor about the alarm system, so when the burglar comes, they should pick your neighbor instead of you. Okay, so to some degree, it's a race. But Christian will talk a little bit more about security later on. So if we look at the old and the new world, the difference is not much. In the old world, you buy a connection from one provider, and then you buy additional services from them. But in the new world, you buy a connection from one provider, and then you buy a service from anyone. And that is why all of you are here, right? This is your goal. Like, your business models would not work if it was not the case that anyone that had an internet access could actually send packets to you and your customers. This is extremely important. And unfortunately, not many people working with regulation understand that this is the ultimate goal of an open internet and open internet access, is to enable innovation, not only in technology, but also business models, enable competition, and allow the market economy forces to act as efficient as possible. So a lot of people think that it looks like this, of course, but in reality, we send the traffic sort of over multiple parties. So given what I talked about yesterday, about a few minutes ago, that anyone that brings something to the internet, connects something, which of course multiple people have done here, multiple parties have brought things, for the traffic to work between the cell phone and the dish and the sort of washing machine down there, you have multiple parties that each one must ensure that their service works. And if one of them is broken, well, communication will not work. And this, of course, makes it a little bit difficult for people because people and also the regulator, they are used to have only one telco, and they knew they were providing the service, and they could also blame that partner when it didn't work. Today, you have multiple parties, and God knows who has screwed up. And you know, and I see many of you are smiling because I guess that many of you have said, okay, damn, the package doesn't really sort of reach whatever I want, but how do I know who has made an error here? Is it Pakistan Telecom again that announced sort of the wrong routes that level 3 trusted? Or like, what is the problem? It's pretty hard to know. So historically, we only had the communication between client-server. But, of course, we see now with everything that you guys are doing, we also have an east-west communication, of course. Of course, many people, specifically this Internet of Things, that I think is completely broken, and that's why I launched Internet of Food instead of Internet of Things. Think about that for a second. People think that they are communicating east-west on the client side, but of course, market economy has shown, and that's why I think it's interesting to meet all of you guys, that each one of the clients are, of course, talking to a cloud service, and then the cloud services talk to each other. So people think that the things are actually communicating with each other, but they are not. So the east-west communication on the client side, unfortunately, I don't see that it's happening, but what does it matter? But what is important is that the packets actually manage to go from the client north-south and then east-west in the cloud and then sort of north-south back again. So that's sort of what I see communications happening. So if we look at the actual communication to come even closer to what I was supposed to talk about, we had this hierarchical like communication thing. We got more and more appearing, and then we had all of these content providers to start to do caching, blah, blah, blah. And then what we have now is more and more direct interconnect, which of course blows the routing tables out of the water. But this is sort of what is going to happen. So what is confusing for people, including regulators, is that, of course, the fiber owner might not be the access provider. The access provider might not be your internet provider. Or the internet provider might not be the telephony provider, and you might deliver telephony to yourself. And then the question is, of course, if things doesn't work, whose fault is it? No one really knows. And it's important, it's really difficult to know. So given that as a background, that is actually kind of messy. Who are we? We are owned by a foundation. We are 22, maybe 23 staff now. Depends on how you count, depending on whether people have signed the paper or not. We have internet connect points in 6 locations in Sweden. Stockholm, Gothenburg, Malmö, Sundsvall, and Luleå. We have all ISPs as customers that exists, and also content providers, Swedish radio, like all of them. So a lot of the traffic on the internet is, apart from the direct peering, of course, a lot of traffic passing us. We run DNS in 55 locations in the world. We have all countries in our part of the world except Denmark and Belgium. And yes, those countries are a little bit weird. But anyway, in multiple, they make good beer, both of them. So we have all of them as customers. So Sweden, Germany, Netherlands, Italy, like France. We're also responsible in Sweden for distribution of time and frequency. So anyways, and we were founded just because the IX was run at the KTH and people didn't really want to do it there. So we needed something more like commercial. So it all started by having just a switch with some ISPs connected to Tele2, Telia, and Sunet. And of course, it started by having Tele2 and Telia not wanting to exchange traffic, but this way it worked. So nowadays it looks like this, and we have basically the same structure in all locations. This is actually what it looks like in Stockholm. So if it is the case that you buy connection to us, you get fiber connection to 2 different locations. You can get everything from fast Ethernet to 100 gig, whatever you want. Price differs, of course. 1 gig is for free. Okay, I think 100 meg for free, 1 gig for free. Never mind. Who runs only 1 gig? So we have these locations, which are actually pretty cool, compared to some of these locations, which are old military equipment facilities, which are produced for having soldiers, where you have 150 watts per square meter. These are actually made for telecommunication. So these are made for 10 kilowatts per rack. Specifically created for telecom. Works really well. So in September 23, so we pass a little bit more than the average, a little bit more than 1 terabit per second over the exchange points. And it increases quite a lot. This is 24-hour average that is more than doubling that is still doubling every year. So, and it's kind of interesting to try to move more than 1 terabit per second. If you think about the backplane of switches and stuff, it peaks today at about 1.4 sort of terabits per second. We also have DNS servers all over the world, and then Johan, that arrived in the back, is sort of the mastermind of our DNS architecture. Welcome from Japan. So, with that as a background, what is actually the problem? The problem is, of course, that people now are depending on the internet. And why is this so different now? Because everyone talks about the dot-com boom happening. When we had the dot-com boom, we had about 93 million things connected to the internet, and now it's sort of much, much worse. So how come we had so much growth then? Well, the good thing with the dot-com boom was, of course, that so many companies went bankrupt. So they had to write off all the fiber investments they made. So for us that rent fiber, it was actually dirt cheap suddenly. So the dot-com boom was actually good for the internet, not bad. So anyways, in 1984, we had 14 gigabyte of data over the internet each month. In 2014, each user had 14 gigabytes per month. And just the last 15 years, the amount of traffic of the internet has increased more than 500 times. The growth is not decreasing. When I was at Cisco, which was until 4 years ago, in 2011, I made this slide, and I envisioned video content be the most important driver between around 2013, sometimes between 2013 and 2025, video content would take over and video communication would come after 2025. And people said, you're crazy, we will not get that fast evolution. Video content over the internet will come much later. Okay, boy, I was wrong. It has actually taken over much, much faster than that. It's absolutely video content. Look at Netflix. If you look at the number of bits over the network. So whatever we do, whatever we internet people say should happen, everyone is saying, no, 6 months from here, the internet will break. The internet cannot handle this or that or whatever it is. Look at radio, DAB, and other kind of crap that we should not have. People say, no, we cannot use the internet for radio distribution. Anyways, so internet will break. So the problem for us then building things and building networks is, of course, the important questions to ask are, do we know what will break? And of course, the whole idea is that we should know what will break. So Magnus, do you know what will break if it is the case you get too much traffic? Do you know when it will break? Do you have the right parameters in your Nagios or whatever kind of alarm system you have, so you get indication before it breaks? Do you know, have you told your investors how you would improve your system so it can withstand stress if you get more money? Do you have the answer of that question? And you see all of these kind of things, yes, of course we have, but on the other hand, like, maybe not. What do you do when things break? So given that you know what will break, which is, of course, a fundamental lesson, the next thing is, of course, what do I do when things break? Because all of us know that we cannot build something that can withstand anything. And the next thing, of course, can partially functioning systems withstand all the traffic? And then the ultimate question, given that we get lots of unwanted traffic that makes our system break, can we minimize that amount of traffic? How do we do filtering? How can we separate wanted from unwanted traffic? So my ultimate thing is that if you are building a network and you don't know what will break if you get too much traffic, then maybe you should try again. Surprise is the danger in our business. Because a packet-based network, because of normal queuing theory, Poisson distribution, etc., a network is falling apart not linearly. When stress increases, suddenly the network falls apart. And Christian, that saw this picture, said, no, it's not like that. It actually works much, much better, and then it's much sharper, and then sort of nothing. Okay. But we can discuss the parameters in the Poisson distribution however much we want, and we need more beer to go through that. The important thing is that there are two different problems. Okay, two different problems. One, how do we communicate and how do we make sure our business works when the network has collapsed? And the other question is, how do we ensure that the network can withstand as much stress as possible? And the number one question for all of us is to focus on this thing. Unfortunately, when talking to regulators and people with very blank shoes or people that would like to be in the military but didn't really qualify, is that they are mixing up these two things because they really like this question. And let me tell you, there are some people in the world that work with the thing there to the right. And yes, what we do at Netnod, part of our thing is that we have got asked to make sure that to work on this thing as well. But this is where we should spend time. Here. Because when our things have sort of fallen apart, have a beer, wait, do whatever you have planned to do when things fall apart, but not more. And this is normal, like MM1 queuing. Those, my master is in math, so I need to have that slide. And then when something's happening, we have this normal sort of feedback loop, blah, blah, blah. You have an incident, what happened, update the book, do something else, learn from your mistakes or whatever. But the mistakes then, of course, like I looked at home, what kind of things are connected to IP? Well, I have chickens. It looks like this when the chicken's not at home. And I have, of course, telephony, 17 missed calls. Okay, that's not due to the internet that I don't answer the phone. Video conferencing to the office in Stockholm. And, of course, no one is in the office either. But that's also not the internet's fault. At least there's a picture. The alarm system uses the internet. I looked at the temperature, including the temperature in my freezer, where I have all my meat. If this one goes up, that's bad. Okay. Everything is run on old switches, of course, and routers. We never upgrade that. So and this is the radio link I have. This is actually from the mast where the radio link is looking in my direction where I live. So, anyways, fragile. Do I know what to do when things break at home? No, I don't really do that. So you see here, this is Arlanda, Swedavia. Press some key to continue. Yeah, right. Another airport, Arlanda Express, didn't really boot. This is in the Prime Minister office in Stockholm. And you don't have to be a time nerd like me to understand there is something wrong in this picture, right? Because time zone is one thing, but never mind. And if it is the case you have these, and this is my home, yes. This is pretty important because I live in an old water mill, and this is the only thing that this is what it looks like when I build things. That's why I have staff nowadays that build things. I promise you, I do not have access to anything at Netnod that is operational. I promise you. So this is what it looks like when I build things. It's an Arduino, it controls water pumps, there's a sensor that looks at what the water level it is. There are some spiders that protect the whole thing. Anyway, so nothing is happening. So this protects my house for being like having water in the basement. Works great. So you see, there's a web server built in. This is my skill set regarding graphical layout in HTML. Okay. But what happens if there's no electricity? If there's no electricity, things will go poof, of course. And this has happened a couple of times. So one of the things we have been working on in Sweden, of course, is what are the secondary effects? So not only do we have unwanted traffic, we might also have other dependencies outside of the sector. Here's one example, electricity run out in Sweden, broken. This is just E.ON, but same thing with the other providers. And we see that Tele2 in this case, I looked at the map at the same time, there is a dependency here. So what is broken might not only be within the sector, it can also be cross-sector. And no, like the government to use these kind of pneumatic things doesn't work when they also need electricity, trust me. Because you need to blow really hard to make these work. So the question, of course, is like, how do you build a network? Well, redundancy, redundancy, redundancy. If there is packet drop, make sure it is not in your network. That's a good rule. Just like the old burglar thing, you must have nicer stickers than your neighbor. Have more bandwidth than your neighbor. If there is packet drop, make sure it's not in your network. 2 path, 3 packet, blah, blah, blah. So the most normal breakage in Sweden is still physical errors. Fiber break, software upgrades, power outage, or surprisingly high amount of traffic. So at Netnod we see these kind of things. Today Anonymous will hit us. Wow, will hit Sweden, blah, blah, blah. And this is the graph over our traffic this day. No sign of any kind of breakage. Of course, the police website went poof, and some other websites poof, but Sweden or the core internet did not really see any problems. not visible. Notice here, this was 2012, 400 gig in our switch. Here's another thing, 700 gig, but look here. This is a Sunday around 8 p.m. This was the first day, it was the first a new season of Solsidan. So people stopped looking at YouTube and watched TV, so it was visible. It was more visible that Swedish television turned on Solsidan than the anonymous attack. So what is unwanted traffic for you? That might be different than what's unwanted traffic for Netnod. This is what it was this fall. Look here, 1.2 terabits per second. There's some increase here. This is interesting. Also 2012. This is significantly higher. This is not anonymous. This was more visible. Sorry, this is not anonymous at all. This was this guy jumping from a balloon. Okay, and everyone wanted to watch him live. That was visible. Here's another one of our customers. 19th of October 2012. What happened? Well, Apple released iOS 8. This was unwanted traffic, much more than anonymous attack. Here's another interesting thing. In Stockholm, all our customers have 2 connections, 2 fibers. This is obviously a fiber cut for some reason. It took like some hours to fix. This is the other fiber. And you could clearly see that this is the start of the breakage. But of course, you also see that there's a clear sign of packet drop during this period of time. From there to there. But this time, it could handle all the traffic, but not for the peak. And this is one of the most important things to know when you build a network, when you calculate your capacity. How much should you invest in redundancy? Is it to carry 100% of your traffic over over all your redundant investments, or is it okay to have some packet drop? You have to compare, of course, from a pure market economy standpoint, the worth of the investment, the risk of packet drop. Very important. And to be able to do that, you must know what breaks if it is the case that you get unwanted traffic. So with that, done. And of course, because time is what I'm working on, I need to give some references on cool time things that you should read. But anyways, this is the key thing. You must know, one should know, what is unwanted traffic, what happens when things break, what you do when things break, and calculate what you spend your money on. Thank you.
Got time for a couple of questions, I think. So just shoot.
Where is the secret exchange point? We had 5 on the map, you said 6.
Oh, sorry, there are 2 in Stockholm. Yeah, so there are 2 places in Stockholm. But it's true that the location of exchange points are sort of known for most people, although the ones in Stockholm are less known than the others. Let me put it that way. So for example, to be more serious, because some of you might be interested in connecting to us, if it is the case that you connect to our exchange point in Stockholm and you are not located at the same premises as we are, we include the fiber in the connection, in the rent. So we actually deliver fiber to your premises. And you will not get the address of the other end of the fiber. Any more questions? I will be here all evening, so we can chat whenever. Yeah, thanks. Yeah, you are.
So that second picture of the other exchange, this fat mining, could that be interpreted as our customers' ISPs not having a plan B in place?
Well, it could be, but it could also be that the ISP felt that, well, this is an advocate amount of investment. To be able to handle 100% and the peak, the cost for that investment will be so high, so it's not really worth it. It's better to, in that case, return money to the customers, apologize in use or whatever is needed. Because they could handle still 3/4 of the time or 2/3. So I'm not saying they made the wrong decision.
Well, which is exactly my point.
Yeah, exactly.
It's not the case that that lining indicates that we necessarily made wrong provisioning decisions, nor that the customers necessarily did wrong provisioning decision.
The important thing is that the customer had made a calculation. Because given that this was the result, they must now go back and say, we did drop packets. Was that part of the plan or not? If it was not part of the plan, they need to reinvest. If it was part of the plan, fine. Yeah.